Well, hello again everybody. Well, I'm hoping to have a rather lazy bank holiday weekend, so I'm not planning on doing very much, but I just thought I would catch you up on what I've been doing in the last week. And as usual for a Friday, my postman turned up again with his sacks full, and my wife had to go outside and give him a hand in the back of his van. And this is what he brought for us. And it's a Hewlett-Packard 1652B. Well, I purchased this through an eBay seller in Poland, and this seller specialises in old military equipment and radio equipment, and I've purchased quite a lot of equipment from them in the past. And historically, it's always been very well described, well packed and quickly delivered. But unfortunately this time I didn't quite get what I was expecting, and it was described as being faulty and coming with 5 pods damaged. So of course what I was expecting was a logic analyzer and then all the leads that come out of it with the clip probes on it. Now unfortunately the clip probes are missing, so without those I can't really do anything with it. I can't plug it in, which is a bit annoying. So I'm in correspondence with the seller at the moment to see if we can find out whether or not the listing was just made in error and that there is no clip probes, or maybe they went missing in transit somewhere. I'm not sure, but hopefully the seller will come through and be able to help me out with that, and if he does, I'll show this in an up-and-coming video. Now this is basically a more modern unit than the 1631D we looked at previously, but it is similar in that it's got the analog scope inputs built in, which I think is a very useful feature to have on a logic analyzer. But the other thing that it's got a disk drive, which means you can store data. But the problem with this particular unit is that all the system firmware resides on a floppy, so you can't actually use it or do anything with it without a firmware disk, and unfortunately I don't have the setup control disk for it at the moment. But I don't think that's impossible to find. I'm sure somebody on YouTube will be able to find me a disk and send me a control program so we can use it. I think what's going to be more of a problem is not having the pods, because these are like hen's teeth to find. So I don't know what I'm going to do about that if the eBay seller doesn't come through. I guess it will, hopefully I'll be able to negotiate something on the price and maybe just use this as a parts machine. It was described as damaged, but it does appear to work and pass its self-test. So as part of its boot up process, it does run some self-tests, which hope you can see at the moment. I'm very sorry, but I think you're going to get a lot of flicker on this. But we can see that it's passed the ROM test, it's passed the RAM test, interrupt test has passed, the display has test, the keyboard has test, the acquisition test has been passed, the threshold test, don't know what that is, has been passed, but it's saying no disk. So it's failed the disk test because there was no disk in it. And then it says load system files. So I can't go any further. If you press any key, you can basically hear the disk drive running. Turn the wheel and the disk drive runs, but I don't get any further with it. Now apart from the display on this being not particularly bright, I think it's pretty good, and I'm sure that we'll be able to turn up the brightness somewhere. Now I haven't bothered to look for the service manual for this yet, mainly because I've got some parts missing. Now if anybody's got any accessories for the 1652B lying around, including any pods or a systems disk, give me a shout. I'd appreciate that. That'd be helpful. But because until I can source them, I'm afraid this is going back on the shelf. But hopefully we'll get it sorted at some point in the future. Of course, the earlier logic analyzers from Hewlett-Packard, you seem to have everything built into the firmware, so you didn't need a setup disk. But it does seem to be a foible of quite a lot of the later units that they'd require this system disk. And unfortunately that's just a bit annoying because I don't have one. So I've just turned the equipment round so we can have a crafty look at its bottom. And you can see that these are the pods that I'm missing here. So we've got data pod 1, data pod 2, 3, 4 and 5. We've also got a HPIB interface, and we've got an RS232. I think that's probably to drive a printer. We've also got a probe compensation output, which is a BNC style output, and I'm assuming that's to compensate the scope probes, although it does seem unusual that they've put it on a BNC like that. We've got an external trigger output and an external trigger input. we've got something here to control the intensity of the CRT there, because it wasn't very bright when I switched it on, so obviously that's what we need to do to adjust that. Now, I haven't bothered to look for a service manual for this yet. As I said, the pods clearly plug into here, but I'm not exactly sure whether or not we could just plug in a cable with some wires on it to plug into the board under test, or whether or not we need the proper leads that have got some kind of compensated header on the end. Certainly the other logic analyzers they've got well, they do call them pods on the end of the ribbon cable, and they usually have some form of like hybrid arrangement or a ceramic board in there that have got some some amplifier in or some controlled impedance logic going on in there, some loveliness. So I'm assuming that this has that as well, so we probably just can't push some wires in to test it. So I think we do need to find them pods, and hopefully if we can get some of them, we'll be up and running again. Now, back in the day, this was actually described to be a portable instrument for use in the field. Well, I have to admit, I wouldn't fancy lugging this up and down a flight of stairs, but I guess back in the day, men were men, weren't they? I mean, I have to admit, it is probably still more portable than some of the larger HP mainframe units that are out there. Mainframe. Want one. So we'll put this to bed for now, and hopefully we'll see you again sometime in the not too distant future. So this is the 1631D logic analyzer that you saw last time that had the dodgy switch. Well, the switch seems to be working okay at the moment, but maybe we'll have to dig a little bit deeper into what's wrong with it going forward. I didn't want to do that at the time because I think the next stage was to take this front off to actually find out if there was any damage internally to where this switch goes through. But that's kind of a bigger job, and I didn't want to get into that. And the other thing was that I think I'm going to use this equipment very rarely, so it doesn't really matter at this stage whether or not the switch is 100% reliable, but it does seem fine for the moment. Now, as you've seen, one of the big differences between this and the 52B that we saw a minute ago is that it's got its own firmware. It's very much self-contained in that it doesn't require any setup disks or anything like that. You switch it on, the firmware boots up, and you're up and running. Now, we haven't played with this very much so far, and one of the reasons is because we didn't have any pods for it. Sorry, we had the pods, but we didn't have any grippers. So just a quick update, what I've actually been doing is I've just made my own little connectors here. Unfortunately, it's not perfect this, but it's probably about as good as I can do. So basically this is just a standard Molex header, and I got some of the crimp terminals, and I've just basically crimped some wires into it. Now on eBay they sell these bits of ribbon cable, and they've got little female sockets at either end. And I think one of the things they actually sell these is to use with, there's a number of these cheap USB logic analyzers that you can buy off eBay for, well, incredibly cheap money, and they tend to come with these. So what I've actually done is I had a few of these just lying around from other test equipment I have, so I just cut the connectors off one end, and apologies, local repeater just fired up there. So lost my train of thread. So I've lost my train of thread there completely. So we bought some of these this connection strip off eBay, cut one end off, just got a Molex header connector, because it does seem that these luckily these pins in here are a standard spacing, and yeah, they do fit a Molex connector. Now unfortunately, one thing I would say about these is though, the wire inside them is really thin. There's literally about 3 strands of wire inside, so I'm not sure how long these will actually last. And the other thing that I found was that the Molex header pins that I found were actually very large. I think they're probably designed for like a 1.5mm cable, and these are just, yeah, well, they're nothing like that. I wonder if I can show you one. Hopefully you can focus in. Now there's actually you can probably count the strands there. Okay, well there isn't. How many strands is there? I can see 1, 2, 3, 4, 5, 6 strands of wire inside there, and they're very thin strands, and they're not mechanically robust at all. It would be nice if there was a little bit more copper in these cables. It wasn't particularly easy to crimp these very thin wires into this this Molex header, because this Molex header, again, I forget what size it is, but it's one of the large. They obviously make these Molex connectors in various sizes, but this is one of the larger housings. I think they were listed as being 12 amp headers. Now these are the crimp pins that I'm using, and I've got to admit I just bought what was easiest when I went on the Farnell website, because I was somewhat daunted by the thousands of different pins and various housing styles and all the rest of the things. So I think I did quite well to actually match these pins up to the actual header connector. So I did manage to give myself some pat on the back there. But these are obviously designed to take quite a thick cable. Don't know if I'll be able to. Don't know if I'll be able to show you that. So that's quite a sizable crimp-on connector there. Now I was rooting round in the drawer trying to find some crimp pliers that would actually fit these Molexes, and I've just actually noticed that these are what I found in the drawer, but they have actually got an RS part number on them, which I didn't see before, 779554. So I could do with actually looking these up to see if they are actually Molex crimp pliers, but it's been a very long time since I've had to fit crimps. God, it's one of them things where when you think back over your career and time flies, it's been at least 20 years since I've needed to fit a Molex crimp onto anything. So I've pulled out these, and I'm not sure whether they're right or not. So I'm just wondering if you guys who work with electronics every day, does that look right for a Molex crimp plier? Well, I know that you won't be even slightly surprised by the depth of my own stupidity, but I've just been looking up the part number for these crimp pliers on RS, and the number on them is 779554. And what it turns out these are is they're a crimping tool for bootlace ferrules. So it's probably not surprising in the least that I was having so much trouble trying to put Molex crimps on with these. So yeah, bugger. Now unfortunately I think I'm now going to have to go out and sell one of my own kidneys to afford a pair of these Molex crimping tools. But it does explain how I managed to make a total bugger of so many of these crimps, doesn't it? Now a few years ago I found this NEC oven controlled oscillator in the junk box. And an unlikely combination of too much free time and red wine led me to want to make this LED flash at 1 Hz. Now, the way I'm actually doing this at the moment is I'm actually feeding the 10 megahertz output from the other controlled oscillator, and I'm just feeding that, and I'm actually using it to clock a microchip PIC chip, and then the PIC chip itself is doing the dividing and flashing this LED on and off at 1 Hz. Now the source code for this PIC chip, which divides the 10 megahertz input into this 1 Hz output oscillator, it came from the Time Nut website, and there's quite a few different PIC oriented projects on there which can produce different output timings for a range of oscillator values and stuff like that, because those guys are really into is it metrology, is it? I forget what the name of it, but you know, in precisely timing equipment and oscillators and clocks and things like that. So I got this idea from their website, and that's where I got the code from. But before I actually got that code, I had a go at home brewing my own version of that, and I've got an example of that here. I'll just show you. Now this bird's nest of a circuit board is one that I designed, and the purpose of this board is effectively to divide the clock input signal by 10 million to produce a 1 Hz output. So hopefully you can see that we've got the green LED flashing away here at 1 Hz, and the actual circuit board itself is being fed from my signal generator up on the shelf, and it's being fed with a 10 megahertz signal at the moment. So just to prove that there's no jiggery pokery going on and I'm not just using this 555 timer to flash the LED on, I'll just unplug the signal generator here. He said, come on, get out. There we go. And hopefully the LED has stopped flashing. Phew, which it has. That's a relief. So we'll plug the signal generator back in again. So just to demonstrate that a little bit further, I'll just set my signal generator to 5 megs because it's at its maximum at the moment. So frequency 5 megahertz. And hopefully that should now be flashing once every 2 seconds, which I think it is. Now, of course, it was actually quite a few years ago that I built this, and like many projects that have been fueled by red wine, I can't really remember how it works in detail, so apologies if I'm a little bit vague. I seem to remember that each of these ICs here is a decade counter chip, and what I basically can do is I can actually, we've got enough digital bits here to store a total count of 10 million, and I pick off each of those binary equivalent for the 10 million number. I pick them off and I AND them together in these AND gates here. In fact, that one might be a buffer actually. Yeah, I think it's just them 2 gates. So basically, we AND together the binary output of 10 million. And what we actually do is, once these have got a count billion of 10 million on them, these 2 ICs here recognise that, and then we send up this green, hopefully you can see that there's a green wire there, and that sends a reset pulse to all the counters. Now, as well as that output pulse going to the counters, I also, I think, use this IC here as a buffer, and that then squirts it into this 5.5 timer, which is set up as a is it a monostable? I'm basically just using it as a pulse extender because the obviously the reset pulse that I send is less than 10 millionth of a second wide, so I just use the 555 timer to extend the pulse long enough to be visible on the LED. So why am I jabbering on about this? Well, I'll get there eventually, like I normally do. Well, I thought what we could do is we could use this board to actually test the logic analyzers going forward, because I was never actually able to verify that these counters were actually rolling over at exactly 10 million. So what we will do in a future video is we'll actually connect the logic analyzer to the binary output of these counters, and we will we'll set up a trigger word to be 10 million. I suppose it doesn't really matter. We could set the trigger word to be all zeros, or we could actually set it to be 10 million. But really what I wanted to verify, just for my own entertainment, is that it does actually roll over at 10 million, and not a few before and not a few after. I mean, of course it shouldn't do, but it's not impossible that I've actually got one of these trigger lines connected to the wrong binary bit on the counters. You know, that's quite possible. In fact, it's highly likely, knowing me, that I made a mistake. So I thought what we could do is we could use the logic analyzer just to verify the operation of this. And because we're able to drive this from an external signal source, what we can also do is increase the frequency. I think, I don't know what the practical limitation of this circuit board is, but I do have signal generators that will happily go up to 1 gigahertz. So it'll be interesting to have a little bit of a shootout between the various logic analyzers to see if they can all cope at those frequencies. And the other thing is, as we start to increase the frequencies, it'll be interesting to see if the logic analyzers load the circuit enough to actually stop it from working. So I just thought that would be a bit of a teaser, and maybe see what any of you thought of that. Would that be an interesting thing to do, or should we try and test the logic analyzers in a different way? The only other thing I thought of is maybe to have a look for a low-cost games console on the second-hand market, something like that. And again, have a go at probing a games console. But I've got to admit, I'm not really into video games and stuff like that. But I do quite like the idea of maybe getting a vintage computer, but I really don't think I've got room in here for a mainframe. And just an update regarding the Hewlett-Packard 37732A that we looked at previously. Now, I'm sure that you'll remember that last time we replaced a lithium backup battery, which was feeding power to the real-time clock and also backing up some of the contents of RAM, which is used to all the settings. And the other problem that we had is that the LE display has this dead section of this dead vertical row going all the way down at about 1 inch wide. And we did pull the EL display module apart and just had a quick look at it. But as I said in the last video, the problem is you can't really probe anything. When the display is installed in the analyzer, you can't get at anything. So the next step is actually to make up an extension ribbon cable. And when we've done that, we'll be able to just remove the display from the actual unit, and we'll be able to run it on the bench. So we can then use the oscilloscope to probe around the various output lines. Now, quite a lot of you were good enough to leave comments and suggestions about this. Now, I think previously I kept referring to the display in this as an LCD display, and since I made the original video and saw some of the comments that you left for me, I realise now that this isn't actually a liquid crystal display. What I thought it was a liquid crystal display that had a backlight, a backlit electroluminescent kind of driver backlight, but it isn't that at all. What this EL display consists of, and again the EL stands for electroluminescence, it's actually just what you might call a normal pixel display, where you've actually got hundreds and hundreds of little luminescent pixels which actually light up when they're energized. Now, thanks to Gironi, he left me some links to the Wikipedia site where I did read about the EL display technology, but from reading that it really wasn't clear how this display was working. But I did actually also find some data sheets, and I did also find some other YouTube videos where people had been connecting these things to Game Boys and stuff like that. And I did put some links to those videos in the previous video. Now, one of the comments from Cliff Matthews was about the HV5408P driver chip that's on the board. Well, there's actually a number of these driver chips distributed around the periphery of the display driver board, and he just pointed out that he thought it was maybe a little bit unusual to have a high voltage output driver like this in an LV LCD application. But I suspect the reason we've got this is, again, because it isn't an LCD. It's actually probably much more reminiscent as a vacuum fluorescent display, in that I think it does use actually a reasonably high voltage to, let's call it, excite the pixels to make them glow. So I think that's what explains that. Now, I think the problem that we have is one of those driver chips has actually perhaps blown up. I have had a prod around at the flat flex cables which actually join the glass panel onto the PCB, and I can't actually find any problem with those, although it's very, very difficult to get access. But just in case we're not able to fix it or get spare driver chips, I've also ordered a spare parts machine from the United States. So hopefully we'll just swap the old unit when we get that parts donor, and we can then maybe just play with this separate EL display at our leisure. So that's an update on that, and hopefully you'll be seeing that again in a future video, and maybe next time the display will be working properly. I've still got absolutely no idea what I can possibly do with this piece of equipment. It's of no use whatsoever to me, but yeah, more test equipment is better than less. Anyway, I think that's about everything for today. So today, thanks very much for watching. Anyway, I think that's about everything for today. Well, as always, I've enjoyed you joining me at the bench today. Hope to see you again. So today, thanks very much for watching. As always, thanks for watching. Please like and subscribe. Idiot.